Okay, today we're looking at geometry notes 5.4, but the first thing we're going to do is correct 5.3. Okay, we're looking at 5.3 corrections, and honestly, if you got questions, you got to make sure you get answers to them today. 1 through 4 questions. We're doing okay. Very much like the stuff we did in notes. 5 through 10, I think 4 of the 6 are the ones from notes. Okay. In 11, P is equidistant from the sides. That's what I know. 12, false. The incenter is equidistant from 3 vertices, not the circumcenter is equidistant from the vertices, not the incenter. 13, true. It is made by angle bisectors always inside. 14, false. Any 3 non-linear points in a plane cannot have a circle. I mean, 3 collinear points cannot have a circle through it, but it's any 3 non-collinears can. Okay? Yes, Mr. Stroud. In 14? Well, you got to think about it. If they're linear, how can I put a circle that goes through all 3 of them? I mean, I can't. It won't happen. They have to be non-linear points. So that's where it's at. They got to be non-linear so I can put a circle through it. Conceivably putting a circle through it as I go, if I can actually move my circle to include those points. Gosh, that's really off. But if I move my circle to include those points, it's got to be non-collinear. If they're collinear points, can't happen. Okay. Now, other questions in that section. Let's talk about problem, 16, and that's 1-1 because, gosh, whiz bang, that's exactly what we did when we were doing notes today. And the number 1 question of the day, Bloom, are you serious about problem 15? Now, here's the thing about this. The stuff we've been doing has been helpful to give us a starting point for the things we need to do, okay? Everything we do, there's always something more to push the envelope of making the problems more difficult, making it more challenging for you, the student. In problem 15, I'm combining the ideas of circumcenter with the ideas that we learned in chapter 3, or I should say reviewed in chapter 3, of writing equations, linear equations. So let's talk about this first. Perpendicular bisectors make the circumcenter. And if I find the perpendicular bisector here, okay, that's perpendicular, it's going straight up. I wonder if I can move that over, I can't. Okay, but I want to be clear about this. This is the equation there's an equation for that line. It's a vertical line. It's x equals 0, okay? So I've got x equals 0 is my equation of my perpendicular bisector, okay? The first segment, or line in this case, to help me find my circumcenter. The other one is located off the midpoint of this side. So I'm going to work on this side first. I got 3, 0 here. I got 0, 5 up here. 1, 2, 3, 4, 5. Yep. And I'm going to find the midpoint. So I got 3 halves and 5 halves. My midpoint, 3 halves, 5 halves, right there. Okay, so I just found midpoint, and some people are like, okay, that's fine, Bloom, but what do you mean by finding the line coming out of there? Remember, I can find another perpendicular bisector equation here. When I do that, what's going to happen here is it's going to come out of there and come right down through there, like that. Okay, I'm going to find this point, my circumcenter. I will not only be able to have a general, hey, it's right there. I will tell you exactly what the x and y coordinates are. Because once I write the equation, that blue line equation, I will have an opportunity to use systems of equation solving by substitution to find my y. Because I already know x is 0. x is equal to 0. That's the beauty of having it being a vertical line. It's pretty cool. I just pop that in and I solve for x. So my next step is talking about my slope. I already know the point that my line has to go through. I need to know the slope. And one of the review things that we need to recall is the fact that slopes of perpendicular lines are opposite reciprocals to the lines they are perpendicular to. So if I look at the slope of the green line, the slope of the green line was a rise of -5, a run in 3, so it was -5/3. The slope of the blue line needs to be the opposite reciprocal, 3/5. Okay, now I'm going to take my point slope form and I'm going to pop in what I got. And you got to keep in mind what I'm popping in: y, x, and slope. So y minus 5/2 equal 3/5 x minus 3/2. Now keep in mind on this part of this solving, I got to find my y and I put in 0 for x. So when I get that done, make that 0. I keep solving. I got y minus 5/2 equal -9/10. Now I have to have my y by itself, so I got to add 5/2 to both sides. But I'm going to do it in such a way that it's one move. I'm going to put it in terms of tenths. So I'm going to multiply the top and bottom by 5. That changes my 2 to tenths. So it's 25/10 and 5/2 is the same value. So I'm really adding 5/10 to both sides, or 25/10 to both sides, excuse me. So when I get done, I'm going to have 25 plus -9 is 16/10, which is the same as 8/5. Okay. Now, I found my y value and I know my x value. So my circumcenter is located, or better yet, my hay bale is located at 0 and 8/5. Now, that was a really nice question to be able to use that stuff on, because I had that vertical line be 0. That was awesome. Okay? I mean, I could increase the difficulty of this because I would have you find a different line that's not that nice. Okay? But we had a horizontal and a vertical line to help us out. It was totally awesome. Not an impossible question, but challenging, right? I mean, there's a lot of things going on in that question. Okay? We used perpendicular lines. We used writing an equation. Okay? We used slope. We used vertical lines. We used systems of equations. We used the idea of circumcenter. Okay? Wow. 6 different things. 6 different topics in that one question. Okay? Pretty involved. Okay. Are there any other questions other than 15 as we go through? Okay, so here's the deal. If you have questions, make sure that you're asking them. Okay, now we're going to try to make sure that you have time today, get some other stuff done. Okay, we just finished correcting this. We checked our answers earlier, and then I asked for any questions. So put your name on top of this, hand it forward. Keep in mind, your grades have been updated. As of to the moment that your foot hits this class, I am now behind for this assignment and whatever you might have given me late. Okay, now we need you guys to open up your notes to page 9, please. We are looking at 5.4. Okay, we just finished correcting 5.3 day 2 assignment. We are looking at 5.4. 5.4 today is what we're looking at is notes for 5.4 is we're going to learn about medians. They make a centroid. We're going to look at altitudes. They make the orthocenter. And then we're going to do some example problems with those so we get a better idea of what those mean. So let's get on with the show. We have the objective today to identify properties of medians and altitudes of a triangle. Okay, now A median of a triangle is a segment whose endpoints are a vertex and a midpoint of the side opposite that vertex. So this picture provided here, let's use green, or not green, but red. This picture provided shows me an example of a median. It goes from the midpoint, and they either got to tell us that this is the midpoint, or they show us it's the midpoint by marking it, okay, like they did with those marks. But it goes from the midpoint to the vertex, okay? That's what a median is. Now, to clarify a few things that we know, we worked with perpendicular bisectors. The perpendicular bisector is another point that comes from the median. Okay, and let me get these grouped because I can't believe it came ungrouped. Maybe it'll group and ungroup. Okay, so we have the perpendicular bisector also comes from the same spot the median does. So this could be something we can find out, know, and use when we're looking at problems, okay, to answer. One of the things that we need to realize today, yesterday and the day before, we had a theme about what the points did. Circumcenter made by perpendicular bisectors, okay, the distance to the vertices is the same. Incenters made by angle bisectors, the distance to the sides was the same. So we were able to make circles, you know, in-center circles, you know, was the circle, inscribed circle. Circumcenter was a circumscribing circle, okay? Today's theme are segments that come from the side and go to the vertex opposite that side. That's what today's themes is. That's why they're grouped the way they are. So now, keep in mind, today we're talking about an altitude and a median, okay? The altitude's a perpendicular segment that goes from a side, or a line that contains the side, and we'll talk about that in a little bit. And the median goes from the midpoint to the vertex, and both of them go to the vertex opposite the side they start at. So, staying with medians. Medians are centroids. They make the centroid. And the centroid, okay, is the center of balance for the triangle, or gravity, as we go through. I'll give you some time to get this done before we start talking about the next thing here. Now, here's the deal. If you were going to go out, say, get a snack over at Buffalo Wild Wings today, okay? You're going to walk down the road with your buddies, just three of you, okay? And you guys all ordered the same thing, same drink, decided when the bill came, hey, let's just split it up, okay? If there's three of you, you're going to divide it by 3, right? You want to pay the same. If the bill comes to 60 bucks, how much of each are you going to pay? 20. You divide by 3. What if last week you guys went and somebody didn't have money at all, but you know, paid for them, so they're going to pay you back? How much is that person going to pay then? If they're going to pay 2 shares out of the 3? 40, because you just take the 1 share and double it, right? That's all I'm asking you guys to do today. I'm asking you to look at a full thing and split it up into 3 equal parts. And then consider a single share and a double share. And maybe you'll have to add the single and double together to find the whole share. Or maybe you got to break the whole share apart to find a single. And then in doing that, you can find the double share. Okay? But it's about thirds. And that's why DC, EC, FC. DC is the distance from the vertex to the centroid. EC is the distance from the vertex to the centroid. FC is the distance from the vertex to the centroid. You starting to see my theme? The distance from the vertex to the centroid is 2/3 the entire length of the median. Okay? Now, remember, this median continues on. Maybe I should dot that out. That median continues on. And that length of the median is 3 parts. The length from the vertex to the centroid is 2 parts. Okay? And the length from the centroid to the side that the median continues on is just 1 part. So meaning is, if this was 8, this would be 4. The whole thing, dj, would be 12. Do you see that as we talk about that? And we will get to some practice problems to get more practice with this. Now, hey, wait a minute. Bloom, you're switching that fast? Yep, folks, I got news for you. I just showed you centroid. Now we're doing orthocenter. Okay? Now, some of y'all had braces, right? What type of doctor does that? An orthodontist makes your teeth right. Okay? An orthocenter, okay? Perpendicular lines, altitudes that meet inside. Okay? Your teeth are perpendicular, ideally to something in your jaw, probably your jawline is the bone in your jaw so that you can bite right, right? They're fixing it, they're making them right. Orthocenter is where the altitudes meet, okay? Now, altitude is the perpendicular segment from a vertex of the triangle to the line containing the opposite side. An altitude of a triangle can be inside, outside, or on the triangle, okay? So we're looking at the concurrency of altitudes theorem, which is the orthocenter. The lines that contain the altitudes of a triangle are concurrent, that they will meet in, on, or outside the triangle. Which is interesting. The only reason we've used the altitudes of a triangle is really about area, okay? There is a couple things about the location. You know, we call it the orthocenter, the location. Location of an acute triangle's inside. Location of a right triangle's on the right triangle. But here's the thing. On every right triangle, the orthocenter is on the vertex of the right angle. It is right there. That vertex point. Okay? They all meet right there. And in an obtuse triangle, the orthocenter is outside the obtuse triangle on the same side as the obtuse angle. Okay? On the same side of the obtuse angle. Make sure you get this section an asterisk so you know where to locate it so you can put it on your notes for your note card. Okay? We got to make sure we reread this stuff, go over it, do the Quizlet, reread your notes, do some practice problems, okay, to get her done. Matter of fact, on Monday, we have a Schoology quiz. On Tuesday, we have a Schoology quiz. We need to make sure we start getting to it and getting it done. So this is our last day. That'll be quiz free. And Monday, we'll correct this. We'll go through any questions. We'll do a little review. I got another follow-up assignment. And the remainder of my time, I'm just going to have you do a quiz because I'm curious of what we know. Okay? Call me George. Mishner's my friend in the yellow hat, by the way. Okay? Go ahead and tell him that. I should actually get him one for Christmas. All right, so here we go. You ready? In the diagram, XA is equal to 8. What's the length of XB? Go. Remember, 3 friends, XA is 2 shares. Okay? XB is the total of 3 shares. How long is XB? XA is 8. 2 shares. What's half of 8? 4. That's 1 share. Are you okay with that? And now what's 8 plus 4? Let's do that. Are you okay with that being 12? Does it make sense? Okay, now, here's the thing. Our practice always is kind of an I do. Now it's a you do. Go ahead, do two. Yes, sir. Oh, that's a bummer. I'll get it for you here. Good luck. I mean, not that you have to, it's because you have to leave, not because you got to go to wrestling. I guess I should clarify myself, but good luck today. Okay. Okay, so I'm looking at this, and I have this information. ZA is 9. That's 2 shares. What's half of 9? 4.5. So that's a share, because 1/3 of the distance of that median is from the centroid to the side, okay, along that median segment. 2/3 from the vertex to the centroid, okay? So we got 4.5 plus 9 equals 13.5. Okay, are you okay with this? Now, as promised, and I've been promising this most of the week, you're going to come across diagrams. I'm not going to say anything. You have to know how to identify perpendicular bisectors, angle bisectors, medians, and altitudes. You have to realize which one of those 4 make circumcenter, which is perpendicular bisectors, in-center, which is angle bisectors, orthocenter, which is altitudes, centroid, which is medians, okay? And be able to realize what the mathematical connection is. So on this one, just read them and decide which one's which. Okay, we're just wondering about median and altitude, or neither. Remember, go back to the definitions. Medians go from the midpoint to the vertex opposite it. Altitudes are perpendicular to a side or a line that contains the side and goes to the vertex. So check them out. Nope. Thanks a lot, boys. Okay. So we've got this thing going on. This is a midpoint. B is the midpoint. They tell us that pretty much by making those markings. Going to a vertex, it's got to be a median. Okay. Remember my definition of an altitude. An altitude is the perpendicular distance from a base to the vertex, or a line that contains the base. In a triangle, it has 3 bases. You can identify them all 3. You just got to identify them and be able to find an altitude. In this case, I have an altitude coming from the base, or a line that contains the base. This is not part of the triangle there. That's just showing me the distance. I have a flag in my room. There is a little pointy part of that flag stick, I guess it would be, that's at the top. If I were to measure it, I could drop a measure straight to the floor. But it's not part of the flag. It's just measuring how high that little point is. Well, that's all I'm doing here in B. Okay, I'm just finding how high is that above what I'm going to consider my base. So that's an altitude. Now in this next one, although it is not in the middle, and it's pretty obvious for most, but there's no markings, but I do have, no markings for it to be the midpoint, but I do have perpendicular. Perpendicular and goes through the opposite vertex, altitude. And the last one, I'm looking at this. B isn't in the middle because that first part is 2, the second part's 3, so it's neither. Okay? Are there any questions? Okie dokie. Let's go on to the next one. Your turn. I'm giving you kind of like a playground. A is ABC, and so is B. But then I'm adjusting the size of the playground for us to look at, okay? So in A, find the median in triangle ABC, and triangle ABC is the whole triangle. And Keep in mind those things that are important. Oh, it's on the edge of breaking. Better be careful there. We took care of it. We took care of her. Just making sure people can stay on task. Okay, so now here's the deal. Median. Median has midpoints. I gotta look at the diagram and find something that's marked with midpoint type markings. Okay, I's the midpoint, J's the midpoint. Which one of those midpoints go through the vertex of triangle ABC? Do you see that it's IJ or CJ? I'm sorry, not IJ, but CJ. Okay, as we're going through. So make sure you pay attention to those types of markings so we can identify which segment is which. So an altitude. Altitudes are perpendicular to a side and go through the vertex opposite that side. Well, got an altitude here because that's a right angle. So I've got HA. Are you okay with that? Your turn. Do AHC and AHB and AHG for C, D, and E. Check out those three triangles. I see you've been fishing. That's a nice basket of fish. Okay, a median in triangle AHC. Maybe it'll help if I go AHC just like that. I need a median. It goes from a midpoint. Hey, a midpoint, shooting down. Hey, do you see IH? Okay, and you could also flip it around HI. So I'm going to erase our little playground there. And now an altitude for triangle AHB. 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 An altitude. What type of triangle is AHB? It's a right triangle. An altitude is perpendicular to a side and goes through the vertex. Do you see the altitudes here? People are like, why is he making it plural? Everybody see AH? What about HB? Are you okay with HB? The definition of altitudes is the perpendicular segment that goes from A base to A vertex. Yes, sir.
I got H.
You got what? Nah, that's not perpendicular. AG is this here as we come down, and that is not marked as it's being perpendicular to one of the sides, so I can't use it as an altitude. Okay. AG could be a median if I knew CG and GB were congruent, but in this case I don't know that either. So AG is just kind of there to help us with our next little triangle. So our last triangle is AHG, and AG is my hypotenuse of that triangle. But I still have altitudes, again, AH, but HG, as I'm talking about that. Okay. Now we got some practice in problem 5 and problem 6, graphing some points. So go ahead, graph them bad boys. Get them graphed up. Now, I know that triangle's kind of small in the first one, and to prep for this, I did 2 squares was 1 unit, just so you guys could see my stuff on the board without a magnifying glass. So if you want to do that as well, that's okay. But if you don't want to, I understand that too. So, what do you know about orthocenters? Where do they meet on right triangles? It's on the bottom of the previous page. Check it out. Right smack dab in the middle. It hits us right between the eyes. Crazy. Vertex, right angle. Once you draw your triangle, you're done. Vertex, right angle. Vertex, right angle. Boom, boom. Or you could even go on, hey, that was A. Hey, that was A. Done. The thing about properties is once you know them, and you can apply them so much faster than looking them up on your note card. It is actually better for you to have memorized the properties. Now, why do we give you a note card? Is because you might have just kind of a brain cloud just kind of float in there. You go, it's just right on the tip of my tongue. I forgot. So then you look. Okay, it's there. It's your whoopee during the test. But if you prep your note card really well, you don't ever use it because you know the material. Your note card prep is really for future use back in the week of January 21st to the 25th, so you can do well in your final. Okay? That's the whole reason we do the note card. So now, you ready? Let's go back to those three friends going to Buffalo Wild Wings today. Now remember, I don't get any money from Buffalo Wild Wings to like advertise. We have a change challenge that starts Monday in 5th hours. And there is a wing thing that comes out of there for the winning class for 5th hours classes. So, you know, that's why I'm doing it. So change challenge starts Monday. Now, keep in mind, if those three friends go out, they are going to have an opportunity to share in 3 equal shares of paying. This next problem is 3 equal shares of paying. I want you thinking about that. I bring back binomials. You did binomials in Expo. You did binomials in, gosh, probably not in 8th grade. You might have started doing some stuff with binomials. You may not have called it that, but you did it really heavy first semester last year. Now, here's the deal. I'm working binomials. Okay? When we were talking about our MP, MP is 14x plus 8y. I want to know what PR is. PR. PR is related to MP because PR is half as big as MP. Okay? Does that make sense? So if I took half of MP, half of 14x plus 8y equals PR, right? Does that make sense? That's half because that's 1 share. MP is 2 shares. So half of 14, 7x. Half of 8, got 4y. Done. Got my half. You okay with what I did? Does it make sense? Now, my next concern. I have a 1 share and a 2 share sitting right there in front of me, and I have a line. Couldn't I just add the 2 shares to the 1 share and find out that that's 3 shares, which is the whole deal? So what's 14 plus 7? 21. I'm doing this because they're like terms. 14x, 7x, 21x. What's 8y plus 4y? 12y. I am done. That's the deal. Now I have some people that totally freeze on this problem when they see it. Okay, on the quiz, on a test. Don't be one of them. You'll do it today on today's assignment, probably this very same one. Okay, so keep that in mind as we're going through. Now, problem 8 is similar. It is not the same. Problem 8 is similar, not the same. Give it a try. Give it a try. It's our last one. Last thing we got to do today. Now keep in mind in problem 8, you have the full length. All 3 shares are in that full length. If you just wanted to find FD, you would have to multiply that 15x squared plus 3y by a third to find out what's going on. A third of 15 is 5. A third of 3 is 1. 5x squared plus y. Now, it freaked people out to see that x squared. Dude, it's just a variable. I'm all about the coefficients. It's the variables, those variables with the powers that allow me to add stuff together because of like terms. But the coefficients is what I'm dealing with. Okay? They're just numbers. Now, AF is 2 shares of the green. Well, 2 shares of the green. 2 times 5x squared plus y, should have said an equal in there, is just I should move that down. 10x squared plus 2y. Are you okay with what I'm doing? I don't want it to be magic. I don't want it to be hocus pocus at all. Okay, by the way, it's one of my favorite rabbits, Hocus Pocus. Can you name the show, the Christmas special? Hocus Pocus? What? Wrong. Thanks for playing. Next. Yep, Levine. Frosty the Snowman. It's the little rabbit, the magician's rabbit. Okay, this Hocus Pocus. Okay, so I got the notes done for today. Okay, make sure you're getting your work done. Make sure you're asking questions and stuff you don't get, but make sure that you're rereading your notes and getting after that Quizlet. That's today's thing on top of the 5.4a worksheet. Okay, have a great day.